Welcome back to Java Internals Crashcasts. I'm Sheila, and I'm here with Victor to dive deeper into the fascinating world of Java concurrency. Today, we're continuing our exploration of the Java memory model, focusing on the volatile keyword. Victor, are you ready to demystify this powerful yet often misunderstood feature?
Absolutely, Sheila. I'm excited to break down the volatile keyword and help our listeners understand its crucial role in concurrent programming. It's a topic that often confuses developers, so I'm glad we're addressing it today.
Great. Before we jump in, let's set the stage for our listeners. We're currently in the 4th season of our podcast covering advanced topics. This episode is part of the Java memory model chapter, and we've just discussed the happens before relationship in our previous episode. Now let's kick things off with a quiz question for our listeners. Victor, would you like to do the honors?
Certainly. Here's a question to ponder. True or false, using the volatile keyword guarantees that operations on a variable are always atomic. Take a moment to think about it, and we'll reveal the answer at the end of the episode.
That's an intriguing question, Victor. It touches on a common misconception about volatile, and I'm sure our listeners will be eager to learn the answer. Now, let's start with the basics. Can you give us a brief explanation of what the volatile keyword does?
Of course, Sheila. At its core, the volatile keyword in Java is a way to ensure that changes made to a variable by one thread are immediately visible to all other threads. It's like putting up a news bulletin board that all threads can see and read from instantly.
That's an interesting analogy, Victor. So, if volatile is like a news bulletin board, does that mean it solves all our concurrency problems?
Not quite, Sheila. While volatile is powerful, it's not a silver bullet. It primarily addresses visibility issues, which are just one aspect of concurrent programming challenges. To understand its strengths and limitations, we need to look at how Java handles memory when multiple threads are involved.
That makes sense. Can you explain what you mean by visibility issues? Why don't changes to variables automatically become visible to all threads?
Great question. Imagine each thread has its own notebook where it jots down the values of variables it's working with. The problem arises when one thread updates a value in its notebook, but other threads are still looking at their old notes. They might not see the change immediately because they're not checking the main reference book where all changes should be recorded.
Ah, I see. So volatile somehow prevents this notebook problem?
Exactly. When a variable is declared volatile, it's like telling all threads, hey, don't trust your notebooks for this variable. Always check the main reference book. This way, any thread reading a volatile variable always gets the most up-to-date value, no matter which thread last changed it.
That's fascinating. It sounds like volatile could be really useful in certain scenarios. Can you give us a real-world example of where it might be used?
Certainly. One common use case is in flag-based shutdown mechanisms. Imagine you have a long-running background task that periodically checks a stop sign to see if it should finish up. By making this stop sign volatile, you ensure that when the main program flips the sign to stop, the background task will see this change immediately and wrap things up.
That's a great example, Victor. Now, let's increase the complexity a bit. You mentioned earlier that volatile primarily addresses visibility issues. Are there other concurrency problems it doesn't solve?
Absolutely, Sheila. While volatile ensures everyone sees the latest updates, it doesn't help when you need to do multiple steps as one uninterrupted action. For example, if you're trying to count how many people enter a room, volatile ensures everyone sees the current count, but it doesn't prevent two people from trying to update the count at the exact same moment.
I see. So if we needed to perform these multi-step operations without interruption, we'd need to use other tools, right?
Correct. For those situations, you might need to use more comprehensive tools, like synchronized blocks or special counter classes that Java provides. It's crucial to understand what volatile can and can't do to avoid tricky bugs in concurrent programs.
Speaking of tricky issues, I've heard that volatile also has something to do with the order in which things happen in a program. Can you elaborate on that?
Excellent point, Sheila. This brings us to one of the more advanced aspects of volatile. In addition to ensuring everyone sees the latest updates, Volatile also acts like a do-not-pass sign for certain program instructions. When you update a volatile variable, it's like drawing a line in the sand. Everything that happened before that line is guaranteed to be visible to other threads that read the volatile variable afterwards.
Wow, that's pretty powerful. It sounds like Volatile is doing a lot behind the scenes. Are there any downsides we should be aware of?
Indeed there are, Sheila. While volatile operations are typically faster than using more heavyweight synchronization, they still come at a cost. Reading and writing volatile variables requires more coordination between different parts of the computer, which can be slower than working with regular variables. As with many things in programming, it's about finding the right tool for the job and understanding the trade-offs.
That's great advice, Victor. As we wrap up, could you share some best practices for using Volatile?
Certainly. Here are a few key points to remember. 1. Use Volatile for simple flags that are read and written by different threads. 2. Don't use Volatile for operations that require multiple steps. Use other synchronization tools instead. 3. Be cautious when using Volatile with very large numbers on older systems, as updates to these might not happen all at once. 4. Remember that Volatile doesn't prevent multiple threads from writing to a variable at the same time. It just ensures they all see the latest value.
Those are excellent tips, Victor. Now, let's reveal the answer to our quiz question. True or false? Using the Volatile keyword guarantees that operations on a variable are always atomic.
The answer is false. While Volatile ensures everyone sees the latest value, it doesn't make multi-step operations happen as one uninterruptible unit. Only simple reads and writes of the variable itself are guaranteed to happen in one go.
Thank you, Victor, for this enlightening discussion on the Volatile keyword. To summarize the main points for our listeners. 1. Volatile ensures all threads see the most recent updates to a variable. 2. It creates a sort of checkpoint that helps maintain a consistent order of operations across threads. 3. Volatile doesn't make complex operations uninterruptible. 4. It's great for simple flags, but has limitations for more complex scenarios. In our next episode, we'll be discussing memory barriers and instruction ordering in more detail, so stay tuned.
It's been a pleasure, Sheila. I hope our listeners found this deep dive into Volatile helpful. Remember, understanding these underlying concepts is crucial for writing efficient and correct multi-threaded Java programs.
Absolutely, Victor. And to our listeners, thank you for joining us today. If you found this episode valuable, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue creating in-depth content on Java internals. Until next time, happy coding.